So thank you very much for joining me and us today. Super excited to have you here to talk a bit. The first thing that I'm going to do is I'm going to let everyone introduce a bit who they are and what their company does. And so we're going to start with Alex.
Thank you, Marco. So first of all, thank you for having us here. Thank you for having me here. I think this is a great venue, a great conference, and I'm really happy to be here. My name is Alex. I'm CTO and co-founder at Celos. And at Celos, we automate electronics engineering. Now, since you're all engineers, I can go a little bit deeper. We're actually automating PCB electronics engineering, meaning we're using semiconductors, but we're not in the semiconductor business. We're a software company that provides tools and automations to help people use semiconductors and other chips and components to design electronics, to design PCBs. And I mean, Marco, you perfectly said it in the initial keynote. Bits, they do matter, atoms matter more. I always like to say electronics is kind of the hidden champion of technologies because, tell you what, no single line of code was ever written and then not executed by electronics. You always need electronics for anything there. And yeah, in 1 minute, cannot explain you what we do in detail since we all know engineering is hard and we're doing complex things. But in a nutshell, we save engineers from reading through thousands and thousands of data sheets, finding the right circuits, the right components. We automate the whole search for circuits and bring together component manufacturers, semiconductors, and the engineers who are actually using their components to create designs at the touch of a button, automating the whole process up to a first initial schematic and a layout. And if you want to know more, you know where to find us. Thank you.
Thanks, Alex. And next we have Michael.
Hi. Also, thank you very much for inviting us, Marco, and it's been a pleasure getting to know the other panelists here over the last 2 days. I'm Michael Kor, co-founder and CEO of Duro. We are a cloud PLM for agile and distributed hardware teams. My background's in electrical engineering, and I spent 20 years designing manufacturing products and spent about 18 years just wrangling the data. Was using what was considered the best in practice for data management, your CAD files, bill materials, supply chain, the best in class PLM software. No matter how much I tried, there were always mistakes in production. And there's no control Z in hardware. You can't undo something, you can't undo a mistake, you can't get back that time or money spent on a bad production run. And I realized a lot of the mistakes were rooted in people. Inefficiencies, the processes demanded too much time and responsibility of people, and that's what was causing all these inefficiencies and mistakes. And being in the Bay Area, I saw on the other side of the aisle, the software industry was exploding in capabilities and automating data management and transparency across teams. Very, very little friction to get your tool chain up and running in minutes to hours. Yet I was spending 3 to 6 months just establishing my baseline fundamentals, the tool chain. This proverbial Excel file problem isn't because people think Excel is a better product, it's because the alternatives have traditionally been too difficult, too time intensive, too much friction just to get the infrastructure up and running, and so we use Excel because it's easy. Well, the technology has evolved, expectations have evolved, the culture has evolved. Hardware engineering teams now fundamentally understand software agile workflows and are looking for that in their hardware tools. They want to be able to get their tools up and running in an afternoon. They don't want to spend 6 months. That's an eternity these days. They can get products to market faster than they can set up their tool chain. And that's fundamentally what Duro is changing.
Thanks a lot, Michael. Great to have you here. And next is Rich.
Thanks for having us. And piggybacking off what Michael said, Epsilon 3 is another software tool. We do operations and procedure management platforms. We try to make sure that the right procedure is in the right hands at the right time. We've been talking today about the pace of innovation and how easy it is to lose insights from your team. And we really strive to make sure that as the entire team works together, engineers, operators, we're capturing those insights in real time, making sure that you can keep pace with your growing manufacturing lines, your aerospace testing. Our goal is really to make sure it is a closed innovation loop. We want to make sure that if you've got somebody who knows something wrong, it's corrected in real time, and you can't lose that. How many times has that sticky note fallen from a monitor? losing that clutch, and I think we all know the cost of mistakes in aerospace. So that's what Epsilon 3 is working on and trying to simplify for all your growing teams.
Great to have you here. Thank you. And last but not least, Moritz.
Yeah, thanks, Marco. Welcome, everybody, from my side. I'm Moritz, co-founder and managing director of Elise, also a software startup. I am an aerospace engineer at heart, and we've been doing engineering services for over 10 years and realizing that the tool stack, I guess some of them we have also seen today, especially when it comes from systems engineering down to actually the tools like Nastran and Katia, all those tools, it's a mess. It's like a whole tool chain, and connecting all of these tools in order to come up with automation if you want to handle complexity. It's a challenge, and we struggled with it. So we wrote lots of code of lines of scripts and everything. And we thought, well, this has to be easier at some point. And so we come up with an idea. Why not doing it like a programming language in software? And so we developed a low-code language for engineers. It's a visual programming language that you can see also here on the right side, that enables engineering from end to end over all the silos, from geometry, requirements management, simulation tools. So we are also working together with Valley Space, for example, and really bringing in all the tool sets into one place where engineers can do great stuff.
Great to have you here. Well, I said last but not least, but actually was lying because there is another last but not least. So I'm Marco. I'm one of the co-founders of Valley Space, and we are the leading collaborative systems engineering platform out there. And what we help people is to help along the life cycle from early requirements engineering all the way through managing system data, and then making sure that in the end you can iterate on that data, make trade-offs, and end up basically with test procedures, a product that you actually want to bring out. So I'm really looking forward to this conversation between us, and I would like to start basically by looking at the question of I would like to look at the question of 10x basically. In the title of this talk, we said 10x. So in your experience, and maybe we can start here, Moritz, what does make a team 10 times faster or 10 times more efficient? How much of it is people? How much of it is processes? How much of it is tools? And how do they interrelate?
That's a super interesting question. I would say people first. I mean, if you do not have the right mindset, we've heard it, the right culture, you can have the best tools and they will not work. So definitely you have to have the spirit of maybe failing fast or iterating fast. And this comes with the culture and also with the kind of education that people have, with their mindset. So we're realizing this, for example, with one of our customers that are, I don't want to name an age or something, but if we are above 50 or something, you're kind of tending of being like stuck to the old world, and it's kind of hard to overcome these like processes that you're used to. And yeah, the younger the people get, the more like agile they think. And so this is like the baseline of everything. And then tools can help to facilitate, in my opinion.
That makes sense. And Michael, I know that like PLM used to be a very top-down decision usually, right? Like there was a company and it decided, we now need PLM, let's close this place for 2 years, let's do an integration, and then let's open it back up. How have you seen the difference and change between top-down decisions and bottom-up pull in these 10x teams?
That's great. Well, the way we see it, there's lots of tools that are used to manage your data, and they all have to talk to each other, and depends on your team on where the data starts in that flow. Doesn't matter where it starts, the whole ecosystem is a garbage in, garbage out problem. And so we focus at where's the data going into the system, and that's typically the engineers, so it's a bottoms-up approach. And when it comes from a top-down, the traditional way of selling software to the CIO or CTO, engineers are the ones who bear the brunt of those poor decisions, because then they're forced to use bad tools, inefficient processes, they take shortcuts, they continue to propagate the mistakes. And so our fundamental belief is start at the data entry process, which happens to be the engineer, but everything else will fall in suit.
Absolutely makes sense. And as products evolve faster and faster, right, we see that the products themselves become more complex, right? We've heard today a lot about the physics behind it and so on, but also the tools and processes are evolving at an immense speed. And Alex, if you think of how these processes have been working for the past 20, 30 years. We've probably seen more change in the last 5 years than we have in the 25 before. Um, how do engineers make sure to keep up with that change in pace of knowing what's possible so that they don't get trapped in, well, we've done that before, that's how we do it again?
Well, I think there are two topics to this. Number one, or two answers to that. Number one is, well, as engineers, we tend to anyway be quite rational, but still it is important to be and stay data-driven. So I think that is one general thing that everybody needs to constantly reevaluate how you are making your decisions. And then the second part is, which is kind of, yeah, it's a balance, is focus on your strengths. And to be honest, I mean, I'm also as an engineer from my background, I truly believe that the true strength of people and humans is creativity. And you always now have to strike a balance. You still want to be data-driven, but you strive actually when it comes to creativity. And that then means you need to pick your tools and your tool chain. It's not just one single tool anyway. That's I mean, the world will be connected, and since every iteration will be, and the cycles will be ever so faster, you need to look holistically into your tool chain. And then you need to make sure that, let's over-exaggerate a little bit, that engineers, they're not supposed to be fancy calculators. They are way more, they transcend way more than just calculations and those small details. So you need to be really sure that your team and everybody, in my dream would be that every engineer is really working on the cutting edge, creative, new stuff, and not the small details, or literally just looking up some items in a data sheet or in some table. And this is hard because, well, physics and the nature is kind of hard of that problem. But we need to make sure that we empower every engineer to strive towards that and build only rocket science. That's kind of what I would like to see.
Yeah, we actually did a study once, and we looked at engineers. We asked them, like, how much time do you spend on specific tasks? And we found out that 84% of engineers' time is spent on non-engineering tasks, right? It's spent on looking for data, updating documents, trying to assemble and exchange information. But at least when you define actual engineering work as being making trade-offs, taking decisions, optimizing designs, the amount of time that people spend on this is so low. And I've not found a single engineer who told me, but I really like the work of updating stuff, right? Like, it's not the core and essence of anyone, right? They're all about understanding things. They're all about standing in front, sometimes in a group, sometimes alone, and cracking a problem. And I think one of the core challenges for these engineers is they used to only have to focus on their products in front of them, right? Today they have to focus on the product and also on how to work, right? It's an evolving part in top. I think Ben said it very good in his talk before, right? Like you manage the product and you manage the tool chain of how you get there. But the reason it's worth to do these two things at the same time is because one is a factor of 10 that will help to the other side. And I think staying on top of this is really important. And maybe that brings me to the next part. And the question is, well, but people have been doing engineering work forever, right? We saw that people have been sending rockets into space and so on. It apparently works, right? Like something works. Engineers have created outputs. When's the point in time for an engineering team or for a single engineer to decide, I should go away from that spreadsheet and I should probably take a tool for that? What do you think, Rich?
I think the earlier you bake that muscle memory into an organization, the faster they can move. I think any organization, that's doing hardware is limited by the amount of coordination they can bring to bear. And I think we all know the costs of poor outcomes in aerospace. I think the more eyes you can bring to bear on each problem matters as well. And I think what's changing now is, I've seen your schedules up on the screen today. Yes, we get rockets into space, but we've never tried to get 3 rockets into space in a long afternoon. So, we've built a plane in 30 years, not in 5. So I think starting with the right tool, to your point, eliminating as quickly as possible that engineer doing anything other than engineering and keeping all those engineers helping each other, supporting, and not doing those non-value-add tasks. It sounds like you guys are spending a majority of your time finding the best humans on the planet to solve these problems. And so you don't need them learning Excel. You need them building your vehicles.
Yeah, and go ahead.
Yeah, and to that point, as soon as you encounter yourself saying, well, this should be easier, that's the first trigger point. I think there is not a clear, let's say, okay, now is time. Like, it's not like a bell that rings and then all of a sudden you have to change your tools. But as soon as you have that feeling that, hey, this could be easier, or we're actually doing repetitive things over and over again, that's at least an indication that you should start thinking about your tools in your tool chain. And this is an evolving process. Like, there's no silver bullet that would just say like, yeah, it's those trigger points and then you change your tools now.
Yeah, because there has never been a software engineer, I think, that's wrote an email and said, hey, can you please send me again lines of code 37 to 48 because I would like to recompile. But for some reason in engineering, although it seems like a stupid thing to do, we have gotten used to that's just how it is, right? And probably it's hard to take that step back and to think like, oh, would any other person be willing to go through this? If not, maybe there's a better way of doing it.
Well, I think what's really exciting about the times right now is there's a huge cultural shift that's happening in the hardware industry. It was brought up in one of the earlier talks. The gray hairs are, with all due respect, retiring and making way for the newer generation that is more accustomed to these software workflows. And they're looking for the tools that implement those best practices that were evolved and developed in the software industry. Like, one of my favorite analogies, other than the one you just brought up, like no one's asking, a software engineer doesn't ask to email your software files, is the software industry leads with setting up their tool chain, right? The very first line of code a software developer writes is git init. They set up their tool chain, they set up their GitHub repository, and then they start writing code. There needs to be a cultural shift for the same thing to be thought of as in the hardware industry, because today, most hardware teams start just diving into CAD or start diving into requirements. And then when it's convenient, or they're at like an oh shit moment, we're gonna lose a lot of information here, then they lag with setting up their tool chains. And so part of it's just been the traditional tools are so expensive, or friction, and expensive not just being cost, but time, to set up the tools. And so no engineer thinks it's a good idea not to have them. It's just there's so much force that needs to happen to get to that point. So that needs to change, but as does the culture that demands the tools be better. And that's finally happening, which is really, really exciting. As was brought up earlier, the average age of this conference is much, much lower than a traditional hardware conference. And that's really exciting. And so it's finally nice to see that the demand is changing, and that forces the tool providers to get better.
But I think we're lucky because I don't think we have to wait for the age gap basically to close. Like, one thing that we found at least is engineering teams start new projects every now and then, right? There's always a new project coming up because you're not building this thing, then letting all your engineers go and just hand it to the production crew, right? Like, you have more things in the pipeline that need to be improved and so on. So a new project comes up. And what we found is that a new project is always like in theory, it's at least a clean slate of hands, right? Like, you can start from scratch and like think, how do we want to do it now? And the best companies that we've seen executing is companies that said, okay, let's in this project do it right this time. Let's in this project start not repeating that same mistake. And there is a chance, therefore, that if you didn't get it right last time, you can get it right this time without having to wait for years and years until your organization has changed.
Yeah, true. But to that point also, I think it's important to really take everyone along the road, especially because we have to remember, like, there are actually way more problems to solve than we currently have people. And every engineer counts in that sense to me, because even to the point of, let's say, the people that are longer in the industry, or also people that are very young in the industry, actually, at least for the electronics industry, that's what I'm quite familiar with, we don't have nearly enough young people entering the industry right now compared to the demand and the, let's say, the changes we actually all as just citizens and consumers have been accustomed to. Like, there is a new iPhone, a new technology, a new gimmick, not every 2 years, not every year, every 5 months. And this creates such a pressure on every team that we need to somehow, and that's actually on us as tool providers, to take them along and help them step by step to relieve that pressure. Because right now, they're sometimes really under pressure. And if you now come and say, okay, also change your tool chain, if that is, again, not really integrating into their existing flows, that just makes it worse. And I think no engineer actually wants to do those, let's say, boring tasks of reading through data sheets, et cetera, et cetera. They have to, and at the same time, also focus on the creativity, and that then makes them being stuck between a rock and a hard place. And I think we need to really do something about that.
And that's a perfect way to come to my next question, right? Like, it's not about a tool, and you said it before, like Moritz, how do you see that? How do you think about tool chains versus thinking of individual tools? Like, how do you see people going about solving bigger problems with a set of tools instead of approaching silos, each with a specific solution?
Yeah, I've been talking to many customers of us, and they always love to do the cherry picking. So they want to have the best software, the best tool for the specific task to get done. And I think this is also how I would like to work. I want to use like the best of breed, if you've heard it before, right? The best tool for the specific job. And I do not want to create a silo out of in this tool, so I somehow have to connect it to the other tools, because in the end, it needs to be aligned into a process. It needs to like get the data of one tool to another tool in order to get the job done, to the hardware built at the end. So I think it's like an ecosystem that we are looking in of a huge amount of specific tools. And I'm a big fan of really having this flexibility of selecting the right tools. But of course, this comes also with a challenge of compatibility. So if you compare it, for example, with Android and iOS, I mean, iOS is a very closed ecosystem. Everything works perfectly. And Android is more like the open system. So I think that the Android approach is for engineers, it's the better choice to be able to connect, maybe also like tools that you have self-written into a workflow. Because, I mean, looking into aerospace, and I guess also for space, it's similar. You need to have like the qualified tools that you need for your processes. So you cannot choose. You have to somehow use them because it's mandatory from the regular tool regularity. And so, yeah, they have to fit in somehow.
And when you have these tools, like, what do you think, Rich, should engineers, what should they be able to expect from tools, and what is still their job? Like, where does it end of what a tool should do for them, and what is the thing that definitely lies in their responsibility?
I think the flexibility you mentioned was absolutely clutch. And I think the job's not done till the data's in the right place. So the interoperability is key. I think we've all had the jobs where we had the swivel chair. You finish up doing something on one screen, you turn 10 degrees, and you have to start typing the output into the next tool. And what a loss. So I think, all the tools need to work together. Why would you run the test and then fill out the test form on the next screen? Like, we all know that the plane can't take off till the paperwork outweighs the plane. I think is the metric. So anytime you can simplify that data flowing, that's when you've got the right tools.
Well, I love that we're starting to call it tool chain instead of a tool, because there's a hidden implication in tool chain, and that's that the tools will interoperate. When it's a tool, they're not guaranteed to work together. And exactly as Rich says, like, you have to manually take the output from one and manually put in the input on the other. When you start thinking of things as tool chains, it kind of implies, oh, they will just talk together automatically. I don't have to do that job. It takes away a data management job that I wasn't hired to do, and it promotes transparency, which is another major friction point in this ecosystem. Is by tool chain, it means that the data can flow seamlessly to other people, other departments. Engineering data can flow to operations teams, to finance teams. Everyone has to look at the data for a different purpose, but they're guaranteed to be looking at the right data, which they're not when the data is moved manually from one tool to the next.
Yeah, and I mean, taking again the corresponding software world, right? I think no software engineer ever took a library and then expected that whatever he did with that, he would have to manually, every time that the software runs, have to put into some other place, right? The whole point is that you decide on a tool stack, you decide there is benefits and downsides to certain technologies, and there is a thought process going on. So not every tool is right for the right part. But the moment that you did this, sure, there's some glue here and there, but overall, you're going to build a system that is much bigger, right? And I think if there's anything we're probably all dreaming of, is that world in which someone just decides, oh, actually what I want to achieve is I want to take these components and put this together with that, and this is the kind of output that I'd like to have, this kind of tests I want to run, this is the kind of simulations, go, right? And that decision is then implemented into those kind of chains. So I think since engineering is always something new, you cannot expect that everything is just a pre-written button that you click, right? There is always going to be something that people need to come up themselves with because they are trying to build a specific product, but they shouldn't try to invent things that have been done 200 times before, probably, because there's always the need to bring certain kind of data into the next part and so on. Let's switch topics for a second and look also a bit into the future. So I'm interested, maybe Alex, there is a lot of things happening right now in AI. And I know that AI is a topic that everyone just likes to talk about in a very, very abstract terms, but I'd like to bring it one level down, right? So if you look into the technical internet, let's say it like this, over the last few weeks, we have gone from basically image classification, which used to be I can tell a cat from a dog, into generating images. We went from finding out what text says with OCR and so on, recognizing text, into generating text from scratch. What do you think, which of these technologies on a short term, not talking 10 years from now, but like basically in the next 2-3 years, will have a real life impact on engineers?
Yeah, so I think, I mean, going a little bit away from the hype around AI, I think AI is a tool. It has great capabilities. It's not, again, to the point before, it's not a silver bullet that can do anything, right? We have to be careful what we're expecting from it. But I think one of the great benefits of AI is its way of handling legacy information that has been made for human consumption. Now, again, from my, let's say, biggest experience from the electronics industry, there's just a lot of, let's take an example, data sheets out there that have never been intended to be consumed by machines. They were written for humans. And AI is actually quite good at recognizing the content that you can actually then make digitally native and can use in other automation tools, however you want to use it. Then you can have a classical solver. You can also have AI then later on in the pipeline doing generative designs, etc., etc. But I think for engineers right now, there's a huge benefit in tackling all the missing gaps and the blank spots when it comes to data because of the legacy issue, because we cannot also start from scratch. Like, we have to face the reality, and the reality is you have a lot of existing products, a lot of existing processes, and those may not have been used with the latest stack, the latest approaches, and we also need to take care of that, and I think AI is a great tool for that.
And you just mentioned generative design, and Moritz, I know that you've been working with generative design for a while, and for any engineer who has done any CAD engineering in the past, it's like magic, right? Like you in theory, you're just saying, okay, I have these pieces that are stuck here and there. I put so much force on it. Tell me what it should look like and give me the drawing, right? Like, what has been the perception in your experience of people when they then encounter this? Is this something that is welcome, where people are like, that's amazing, that's going to make 90% of my job so much easier? Or is it something that is met with fear of like asking themselves, like, what have I been learning for the last 20 years? Is that something that threatens people, or is that something that excites people?
Yeah, first of all, I guess most of the people take topology optimization for generative design. Yeah, you get these nice organic looking things. You just have a design space and it gives you the best structure. And I guess generative design is more like a methodology how you could come up with an optimal design based on only requirements. This could also be a sheet metal design in the end, or this could be like a, I don't know, a welded design or something. But of course, if you are able to come up with an algorithm where a machine can do all the optimization runs, and this could be a topology optimization algorithm, this could also be just like a parametric design being optimized by some, I don't know, algorithms, evolutionary algorithms. What I experience is that it's a good starting point. So people really appreciate it as a starting point for then detailing their design. And most of our clients, they use this technology in an early concept phase when you do not know actually how the final structure should look like. It's like a starting point, a suggestion of an algorithm where you should put your material, where you should put your load cases and stuff, and then you iterate on this. Maybe there is like, I know, thousands of designs that are generated by an algorithm, and usually those people are not having like one objective. They have like multiple objectives. I know costs and time to market and weight and I know a CO2 footprint, for example. And so for algorithms, it's really hard to say which of these objectives is like weighted more or less. So I guess it's still like an exploration tool for us engineers to select what we think is the best solution.
And I think, I mean, what is very important when it comes to this perception of AI and also the fears that might be associated with that is that we have the right values. That has been mentioned also before in some of the speeches. For us, it's really important to make sure that we take also the humans along the way and do not let them compete against AI. Especially because I think that's again not even the case if you look into other areas, let's say soft development. I mean, since we moved from assembly code to higher level programming languages, that actually did not mean that all of a sudden all the programmers were out of business. That's not true. So we should be careful also how it's not like this is a competition against the existing humans. And if we have the right values, if we have the right approach to how we actually build that ecosystem and build our engineering world, I'm 100% certain that this won't be any kind of issue. As we have discovered before, we have way more problems than people who can currently address those. And I think AI is a tool. It's something to help and empower people, and we shouldn't be afraid. At least in that section, I know that some other people have other opinions about AI in general, but I think for the engineering sector, that is not a concern whatsoever. And there are a lot of reasons, as the analogy with software. There are also other areas where that's simply not true.
And the looking into the past is super interesting, right? Just watching a movie like a few days ago, and you see these people who were like sitting all on the floor, drawing these very, very big like things in physical, all in obviously still like in their suits, and that was the way of how engineering was done. None of these people, once CAD systems came out, decided not to be an engineer anymore, but to be a gardener. They evolved with those tools and had more capabilities. So if we think this a bit further, Michael, what's the kind of technology that you're like most excited about, like that's coming up?
Well, what I'm really excited about is better APIs that are hardware engineering aware. There's a lot of disparate data out there between supply chain, CAD files, bill of materials, and they're still kind of in their own little pockets of culture, and they're getting better. They're digitizing, they're making it more accessible, but it's still these one-off bespoke solutions. And so what I'm looking forward to is where there is not like an RFC, like an IEEE standard, but some type of way that we can guarantee that anybody can access any data at any time with common tools. It all comes down to transparency, right? The more information an engineer has access to, the better their decisions can be much sooner. We've all had that experience where an engineer's picked a part during the design cycle, but then when it goes to production, they find out it's not available or doesn't meet some other criteria, so they have to redesign just because of part availability. Complete waste of time and cost. And so had that information been more easily accessible at the earlier design stages, not 100% certain, but at least they could have better designed for availability or for procurement, and so there'd be less chance of having to do design iteration. And right now, amazing work is happening in companies like Alex's and everyone else's to start to pull that information out of the printed PDFs. But until there's like some ubiquitous capability or access to it, it's still going to be these little pockets of information. And that's what I'm really excited about, is when it is uniformly accessible.
But I think this also requires a paradigm shift to a certain extent, because right now, for various reasons, most of them were at least intentionally good, we do have too many data silos. We do have too many rosy gardens where it's not that easy. And I mean, APIs, yes, of course, I mean, most modern companies do have an API, but an API alone is not, it doesn't stop there on the technical side. We also need to make sure, and that's a tough thing to promote, because of course, companies and existing businesses, they have concerns regarding their IP, their competitiveness, et cetera, but still I think we need to make sure that also the hardware world is a little bit more open and has the ability to open itself more, so that the API is not just a concept or an idea or a technology that's driving certain things. I mean, that's not enough to make it actually beneficial for entire society. We need to also make sure that actually the collaboration, even, I mean, across departments for sure, but even across companies, is fostered in a better way, because right now I think there's a lot of unlocked potential there. And again, we need that potential right now, because we need to, well, address all of those tough challenges.
And that brings me to a question that I prepared, and I'm almost ashamed to ask it now, because we saw these amazing things that on screens that people are building. But I was wondering, what's holding engineers back, right? Where are hoverboards? Where's the flying cars? What's been the thing that has, at least from a feeling perspective, held us back to build all these things? Rich, what do you think?
I think traditionally, and Michael called it out, there was a lot of expense. Everybody was looking for a big change solution. You know, a new tool coming in was organizationally disruptive. I think nowadays, with so much of it shifting to the cloud, so many projects always starting, we're hoping it lowers that burden, that you can try. You know, you don't have a week-long deployment. You can tinker with it over the weekend, see if it meets your needs. I think the other one was, it used to be the data was always stored somewhere in a walled garden. Nobody's suffering lack of data. Everybody's suffering lack of knowledge. And what I think we're hoping now is that the tools can actually help accelerate the generation of knowledge in the companies as well. For instance, with the machine learning, it's another set of eyes. I think we all knew the older technician, as you were pressurizing a tank, you'd see a spike. And that's the guy that always goes, no, that's tank number 2. It does that every time. I mean, that's knowledge. It's the guy who knew where to hit the creaky wheel with the hammer. And I'm hoping that these tools that are coming out now can add that speed, getting up to the 10x by helping bring knowledge to bear. Like, this voltage is going to fluctuate. This one's going to decline. It's okay to proceed. Don't change the schedule.
If I can add to that, it's very passionate for me, the comment you made at the beginning, Rich. What I vehemently believe needs to happen is the cost to fail has to come down. When it takes 2 weeks to get a machine part back or a PCBA back, there's an expense in that if you made a mistake in that design, there's a cost. And so because it's so expensive to make a mistake right now, there's some apprehension to take risks. And there's a lot of double and triple checking, are these designs right? Are these manual processes imposed on top of design rules to make sure that the probability of failing is so low? Well, if we flip it and we say, if the cost to fail is low, take risks, take a challenge, try something new that you've never been able to do before, and there's very little penalty in doing that. That's when the true innovation is going to open up. When you can rapidly design, build, test, and evaluate and try small things in very short, inexpensive, iterative cycles, that's when the real true innovation is going to happen. And that's when we're going to see the 10x, even the 100x in innovation in the tool suites as well as in the companies. And that's what I'm really excited about.
So I think that's absolutely what this name of this conference is also about, right? It's all about iterating. It's iterating fast. And I think if there's one ultimate thing that tools can do to answer the question, how can we help, right? I guess tools can shorten iteration cycles, and engineers will do the rest. Every time that engineers are able to think things through, to try things, to make trade-offs, to build something fast, prototype, learn, fail, they're going to get one step ahead. And the more tools can accelerate that and shorten those iteration times, the more we're going to be able to do. And I think that's a great way to open it up for questions for the audience.
Thank you so much for the discussion. I'm just asking kind of the reverse question, which is, I'm totally on board that tools need to propel human beings into doing what human beings do best, which is kind of questioning and creating new things. What do you think about also the opposite of kind of focusing on the tools that actually help you and using less tools? So like this, what you're talking about is the new ecosystem needs to be built, these APIs, these new standards, these new paradigm shifts. But is there room for all of the past tools as well? Do they all need to disappear? Like the baseline question is pen and paper going to stay here for long? Is it ever going to disappear? Because it's such a good tool, you know, it's such a baseline tool.
I think if you think of the napkin stage of any engineering task, right, where you're like drawing out things and just thinking them through, you're always going to have discussions, pen and paper, and ideally probably no tool, right? Like, sure, if you have to do it over Zoom, use something where you're going to be like doing the same thing, not in the same room. I don't think that part is or should be disappearing. When it comes to execution, there should never be anything that you still do, right? No one wants to watch the Iron Man movie where he makes the decision to do the suit like this, and then he sits a month in updating each part, right? That part is not the interesting part. So I think that's the role of tools. It should always take away that other part and allow to give back the space for thinking and for designing and for engineering.
Where does that happen? Because that's my question, right? Because you said the paper and the pencil, in the end, is kind of still there. So is it happening in the paper and the pencil? Are these tools kind of removing the clutter so people can go back to pencil and paper? Just yeah.
Just from my perspective, curious to hear yours in a sec. Just go back to Iron Man again, right? What does he do? He needs information, so he asks a system for things. So you need to have access to information, right? Then he asks trade-offs to being made, right? Optimize this for speed. You don't want to do this, right? So I think in the process, you don't want to take away those tools in that process. There is things that you need back and forth, and they're going to be digital. They're going to be helping you in that process. So I think if you're in 5 years putting one engineering team in the one room and the other one in the other, and one of them has just pen and paper and really smart people, and the other one has pen, paper, and access to all the data through a smart interface, I'm pretty sure I know which team is going to come up with a better solution within an hour or within a day, right? So I think it's going to be always extended pen and paper.
Yeah, and I mean, extending on that, if we say that the things we should focus on is actually creativity and let's say the human spirit, there is no definition of how that should look like. Is it pen and paper? I mean, some people maybe draw a line in the sand. I don't know how they do it, or just sit and wander around. That is, the thing is, if you look into day-to-day, let's say the day-to-day work of engineers, they don't spend nearly as much time as they should doing these kind of fuzzy ideations, or even just wandering around thinking about a really hard problem, how to solve that. And that's why I think we should have the right and good tools, right? I mean, there's never an argument, and you can even quote me on that, like a bad tool is never good. Like literally, that stands for itself, right? Nobody would advocate for that, and I think we all agree about that. But the thing is, we still, at the end of the day, need to have, I mean, you will have a calculator, no matter how it will look like, right? And this won't be pen and paper, because it's just, well, it doesn't suit the use case that much. But I think tools are not the solution for everything, quite to the contrary, right? That's why I'm saying we need to actually create space with the tools for that other stuff, right? That's the purpose of that. And then I think we can all build, and the entire, I strongly believe the entire human race can build great things together if we allow for that.
One last question.
I was a bit intrigued by the parallels you draw with the tool chains in software world. mentioning things like Git and stuff like that. And I'm wondering to what extent that actually is a little bit, like it's maybe a bit provocative, but the best tools I see in the software world are all tools that are built by people that are not making money out of the tool. So they're like it's Git because Linux needed a better version control, Perforce gone. It's React because Facebook wanted a better front, whatever. All these tools, all these things are free. And the hardware land where background in semiconductors, so I'm like Cadence and Mentor and all these guys. It's a competitive advantage to have a good tool chain as a hardware vendor or as a hardware builder. Your tool chain is part of your competitive advantage. And I don't see that in the software world. So is there anything you would like to, I mean, I don't have a specific question there, but it seems a very big difference in dynamics.
For me, I mean, if you look at React, it's a great example, right? It was not built as charity. It was not built for the community. The way it was built is it was built by a for-profit team to solve their problem. And they found that if they publish it, they can get thousands of people working for them for free, making that tool better. So I think that's a question to the hardware people, better said, right? Like if you've built a tool, don't you want to give it to others so that it comes back better to you, right? Maybe that should be the case. If you've built an optimizer, do that. But I think also in the software world, every person pays GitHub or GitLab or someone who took some of these ideas and put them together into something commercial that not every software company wants to do. No one wants to host software themselves. They just go to AWS. So although it's not rocket science to like host some server, it's still the convenience, and people have done it a million times for tons of use cases, which is probably going to be better than what you can ever do. And I think it comes back to the question, what do you want to insource and what do you want to outsource, right? Like, I mean, we're a team of 40 people. We've spent the last 6 years building a systems engineering tool. If your company wants to have 40 people doing this, do that, and then please give it to the world so that they improve it and you have people working for free for you. But if you want to have people who have worked across industries and seen the different challenges and incorporate things that you don't even know are going to be your problem of tomorrow and solve them for you, I think people should take the same approach as in the software world, which is, well, I guess there's a certain amount of things I'm going to pay for the ability to focus on what's best in my work, right? And I think every company has to do that trade-off every day. But the same, there is for profit in software to take that pain away from people that same way it is in hardware. And I think if we can go to a point where even in the hardware world, people can exchange more, and the moment you bring out a motor and you say, look, I'm not only selling this motor, I'm selling the simulation model of this motor and the properties in a digital way, and you're going to be able to like do something with it, maybe then you'll notice that a lot of other people will come and improve that motor with and for you, and you actually, even as a hardware company, going to have this. But that won't work as long as you give out data sheets in PDF, right? So I think we have to first build up these tool stacks that allow hardware collaboration to happen in the same way that software collaboration works, so that we will see open source hardware, open source things that come on top of each other and help each other the same way, creating those ecosystems. We're running out of time. We're going to take the other questions over the small break. Thank you very much to the panelists. Thank you very much for listening.
Thank you very much.